Welcome to the video lecture series of data structure. Our today's topic is tree introduction and important terms in tree data structure. Hi, this is your instructor Janice Shah. So let's begin with the outlines. Our today's outlines are: first, we understand that what do we mean by tree, then important terms in tree, and then we'll talk about the different types of trees. So let's begin with tree. As we know that tree shows the hierarchical relationship between data elements. In this figure you can see that A is a root node and these are the nodes which are connected with each other. This whole figure shows the hierarchical relationship between data elements. Fine. So that is known as tree data structure. Now here it is root node. So what do we mean by root node? A topmost node of the tree which is designated at the top, which does not contain any parent, then that node is known as root node. In our example here, A is known as root node. Okay. Now the next is leaf nodes. Now can you see this, the change in both the figures? Yes, can you see the change in both figures? Right. So here the leaf nodes, that means the node that does not contain any child node. Okay, sir, how many nodes are there, or who nodes are known as leaf nodes? Here M, V, O1, E, D, these all nodes are known as leaf nodes. Okay, so in leaf node, students, if you can see, the leaf node does not contain any child nodes. Fine. So these nodes are known as leaf node. Now the next terminology is internal nodes. Now the question coming in your mind that, so what do we mean by internal nodes? Okay, so it is very much easy to say when the nodes accept root node and accept leaf node. The nodes accept root node and accept leaf nodes are known as internal nodes. That means internal node contains parent node, yes. Internal contain child node, yes. So the internal nodes are nothing but except root and leaf node, the all nodes are known as internal nodes. So here the green highlighted nodes are known as internal nodes. Fine. Next, parent and child node relationship. Students, any node except the root node contains one node as a parent node. Okay, so here you can see A is a root node. A is parent node. Yes, A is also parent node because it contains that O, U and F. O, U and F as its child node. That's why A is known as parent node. O is a parent node. Yes. U is a parent node. No, U is not a parent node. Fine, because it does not contain any child. Fine. So here the highlighted nodes are known as the parent node. There are other nodes are also there, but I am just taking 2 or 3 examples over here. Okay. So students, if you can see this table, you can say easily that O, F and U contains parent node A. Fine. Then the next is F and L. F and L contains parent node O. Okay. If you can say that E and D, the child nodes E and D contains parent node R. Okay, so here it is all written there that which nodes are known as parent and which are the child node. Now the next is child nodes. So in our tree, each and every node contains a parent node, and the downward hierarchy, in the hierarchy the downward nodes are known as a child node. Fine. Here if you can see this table, that for node O, the P and L are known as child nodes. Fine. The next, if you can see that for node F, you can say that JKM, these all 3 nodes are known as child nodes. Fine. So same like that. Sir, can you tell me which is the child node for node E? See students, is there any child node for E? See, is there any child node for E? Yes or no? No. That means null. Okay. a node that does not contain any child node, that node is known as leaf node. Fine. Let's move further. The next is siblings. See, when the node contains the same parent, one or more node contains the same parent, then it is known as siblings. Siblings means two child and a common parent. So here if you can say, sir, what we mean by siblings. So a node, root node A contains three nodes, O, U and F. O, U and F. All three nodes, O, U and F, all three nodes are known as child node of node A. Now, if we can talk about that O, U and F, then all three nodes has the same parent, then O, U and F are known as siblings of each other. Now, the next, if we talk about that P and L, both contain the same parent, fine. So, P and L are known as siblings. Same like that J, K, M, all three nodes contains the same parent, then J, K, M are known as siblings of each other. The next, see here, if we can say the siblings are Z and H are all siblings, R and G are also siblings of each other. Now, can you tell me, students, if I talk about this L and J, this L and J, if I talk about L and J, are L and J siblings? No, they are not siblings because they both contains different parent. L is from O, J is from F. That means these both nodes are not siblings. Now, see here if you can say that for H and G, so students, H and G are also not siblings. Fine. So I hope what do we mean by siblings, it's clear now. Now let's move further for the degree of nodes. Okay, degree of nodes, in easy terms I can say the nodes connected or the child nodes connected to the node is known as degree of nodes. Here it is written, they talk about the subtrees, that the degree of node is equal to the number of subtrees or child node. Number of subtrees or child node of that node is known as degree of nodes. Okay, so how? Students, if I am talking about the root node A, can you tell me how many child node root node has? Okay, so root node has 3 child nodes. That means degree of root node A is 3. Now once again, if I am talking about the node F, okay, so students, node F contains how many child nodes? 3 child nodes. That means F degree is 3. Now if I am talking about another node which is okay, say R, okay, so R node contains how many child nodes? 2. So this 2 child nodes. Okay, so R degree is 2. So here if subtree, it means, see, the subtree, that means the whole part of node. If we talk about the node D, if we talk about the node O, sorry, not D, if we talk about the node O, then this all the left part is known as left subtree, and another we have, students, so this is subtree 1, this is subtree 1, another subtree, this L, and this is subtree 2. So students, this subtree 1 and subtree 2, that means that node O contains 2 subtrees. Node O contains 2 subtrees. That's why degree of O is 2. So now let's talk about fast about the degree. So if you can say that degree of A, root node A contains degree 3, then if you talk about the degree of P, then degree of P is 2. Okay, now what are the degree of leaf nodes? See, these are the leaf nodes. In the bottom, these are the leaf node. Is there any child node leaf node contains? No. So this is another definition of leaf node, that leaf node does not contain any child node, and another one is leaf node degree is 0. Leaf node degree is 0. Now, see, here the height of the tree. Students, height of the tree is always calculated from the bottom. Okay, now height, see, this is the level 1, 2, 3, 4 and 5. Okay, this horizontal lines I have just created just to understand that what are the levels are there. So students, if you can see, this is the level, highest level, fine. So how to calculate the height? Okay, so height of a node is the number of the edges from the bottom or from the deepest node or deepest leaf node of the tree. Fine. So let me calculate how. If we talk about the leaf nodes, if we talk about the leaf nodes E and D, if we talk about the leaf nodes E and D, students, is E and D height is 0. Height of E and D is 0. Okay, now move further one level. So whatever the nodes containing at this level, height is 1, then 2, then 3, then 4. So height of the node is 4. So let's see, here the height is 0, then at this level the height is 1, at this level the height is 2, at this level his height is 3, at the last level the height is 4. So total height of the tree is 4. Total height of the tree is 4. Okay. So now another thing is, or definition is that when we talk about the maximum level of a tree is known as height of the tree. Fine. So if you can say maximum level, see this is level 0, this is level 0. Now next is level 1, next level 2, level 3 and level 4. So students, these levels, the maximum levels, level starts from the 0. Okay, so 0, 1, 2, 3 and 4. So how many maximum level is? Maximum level is 4. That's why height of this tree is 4. Fine. Now let's move further. The next definition is depth of the tree. Fine. So depth of the tree is always calculated from the root node. How? Let's see. First, making a table for the root node A. For the root node A, students, if we talk about root node A, then the depth is 0, because depth is calculated from the root node. Okay, so there is no distance from the root node, that's why depth of root node A is 0. And but height is, we recently see about the height. Okay, so height is 4. Now the next we have U. So for the node U, students, depth is 1. See, depth is 1 from the root node to U. From the root node to U. So the depth is 1 and height is 3. For the next node that we have is J. For the J, students, if I can see that the height is now 0, 1 and then depth is 2. Depth is 2. 0, 1 and 2 and the height is once again 2. Now the next we have, students, R. Depth is calculated from the top to bottom. Okay, so that is 3 and height is calculated from bottom to top, that's why it's 1. Now moving forward, the next is D. So last is D. So students, you can see the depth is 4 and the height is 0. Okay, so to calculate the depth, you can go from top to bottom, and to calculate the height, you have to go from bottom to top level. Fine. So now the next is ancestor and descendant. Students, in our hierarchy, if you talk about our family or the human beings, your grandparent, then your parent, and then you. So this is a hierarchy. Okay, so in this hierarchy, students, if we can say that the ancestor means the top, the upper side of our level. Like for you, your parent, your grandparent are known as ancestor, and for them, you is a descendant. Now let's see, if we talk about the node J. If we talk about the node J, then it means that for node J, ancestor nodes are A and D, because J is derived from, A and F, because J is a child of F and F is a child of A. Okay, so this is a hierarchy. Okay, so this A and F are known as ancestor node for node J. Now if we move for the next definition, descendant, that means the child hierarchy. If we talk about the node J, students, then this highlighted nodes are known as descendant. Okay, now next is age. That means if we consider about this whole tree, If you consider about this whole tree, if you can see right now there are no lines are connected between these nodes. Okay, so see, the line connected between two nodes are known as edges. Now let me move forward to the path. See, if we talk about F and D, then the path from F and D. Okay, so how to get a path? You have to go from F to J, and then J to R, and R to D. F to J, J to R, R to D. So in such a way, students, you have to go. So this is a path from source to destination. So the highlighted path is here, from F to J, J to R, F to J, J to R, and R to D. So that is known as path. Now the next is types of the tree. So it is very much important that what are the types of the tree, but before that let me show you what do we mean by forest. So forest is nothing but a disjoint of trees. See, this is what tree number 1, tree number 2, and here it is tree number 3. These all trees are not connected with each other, but they all trees are there. Then this is known as disjoint of tree. So that is known as forest. Now the next is binary tree. Students, in binary tree, each and every node contains maximum 2 child. Remember this. Each and every node contains maximum 2 child. Then it is known as binary tree, where one left subtree is there. See, this is the left subtree and this is right subtree. Fine. Okay. Next is complete binary tree. If you can see in this figure, complete binary tree is a binary tree in which the most of the nodes are situated at the left side of the tree. Okay, fully situated at the left side of the tree. If you can see, the right side part is still remaining with some nodes, but the left side part of the tree has contained all the nodes. Fine. So that is known as complete binary tree. Now next we have full binary tree. See, students, if you have two levels, see, this is level 0, level 1, and level 2. 2 level binary tree, level 0, level 1, and level 2. So students, if you have 2 level binary tree, then it must contain at least 7 nodes. So see in this figure, all the nodes are full. Each and every node has some child, except the leaf nodes. Each and every node contains child. There are no empty child or empty nodes are there. Fine. This is known as full binary tree. Next, if you can say how to calculate, there are full binary tree nodes. So total nodes are 2 raised to h plus 1 minus 1. 2 raised to h plus 1 minus 1. Here the height of the tree is 1 and 2. Height of the tree is 1 and 2. So 2 raised to 2 plus 1 minus 1. That means 2 raised to 3 minus 1. It means 7. So there are 7 nodes are there. Fine. In full binary tree, 7 nodes are there. Now strictly binary tree, students. So in strictly binary tree, students, each and every non-leaf node contains non-empty set of left and right subtree. So that is known as strictly binary tree. Now next we have 2-3 tree. Students, if you can say in 2-3 tree, the tree contains either 2 or 3 children. 2 or 3. This is not a binary tree. I am again repeating, this is not a binary tree. Okay, this is 2-3 tree where each and every node contains either 2 or 3 children. Next we have extended binary tree. So extended binary tree sometimes is also known as 2 tree, where each and every node contains either 2 or 0 children. Fine. Next, binary search tree. So binary search tree, here this is very important tree. Okay, we have to perform each and every operation on such type of tree. Here you can see the smaller values from root node. Smaller values from root node are situated at the left side, okay, and the greater values from the root node are situated at the right side. If you can say, sir, it is 80 over there, then all the values lesser than the 80s are on the left side, and the greater than the 80s are on the right side. See here, see the first value is 80, 65. 65 is 80 less than 65, that's why it's on left side. Now next is 30 is less than 65, so again it's on left side. Next we have 50 is greater than 30, so it's on right side. So such like this, the greater values are situated on the right side and the smaller values are situated on the left side. That is known as binary search tree. So that's all, students. Thank you so much.